I'm sure many of you have heard of, at least in passing, the supercontinent Pangaea, but have you heard about any of the other past supercontinents that we've had throughout Earth's history? Let's talk about the progression of supercontinents as far back as we know that existed, starting off with this one, the Columbia, also known as Nuna supercontinent. Now, since Nuna is the oldest, mostly confirmed supercontinent, we do have the least amount of information about Nuna in general. Dates aren't super specific. I've seen sources claiming it was around from 2 billion years ago all the way up to around 1.45 billion years ago, so it could have been most active any time between those dates. Now, as you can see on this map, Nuna didn't really have those recognizable formations that we would see as our modern continents. Instead, it's split up into different regions, such as Greenland, Siberia, West Africa, India, and all of that. Eventually, Nuna started to fragment and split up into different smaller land masses, and that was the end of the kind of first generally accepted supercontinent. The fragments left behind after the breakup of Nuna eventually coalesced back together into our second confirmed supercontinent, Rodinia. Again, since this was quite a long time ago, we don't have exact dates and estimates. This one up here says 1.3 to 1 billion years ago. I've also seen 1.25 billion years ago to around 630 million years ago. Now, around 50 or so million years ago, Rodinia too began to break up and also drift more towards the South Pole. The next supercontinent that came after Rodinia was this guy Pangaea, again more centered around the southern pole. Now, in relative terms, Pangaea was not a very long-lived supercontinent. It only lasted from around 650 million years ago to 500 million years ago, which, in the terms of everything, is not that long. However, it is quite important. This was approximately around the time when we have the first fossil evidence of actual animals. Now, the next supercontinent, and I do that because some people don't actually consider this to be a true supercontinent, is Gondwana. After Pangaea broke up, many fragments came together to form the landmass of Gondwana. However, it's not always considered to be a supercontinent because it was missing quite a large chunk of landmass that wasn't attached to the main Gondwana. It's kind of, I guess, like the Pluto of supercontinents, but we are going to allow it in here anyway. Now, Gondwana existed around 550 to 150 million years ago before finally everything came together into our most recent supercontinent, Pangaea. Now, the timeline between Gondwana and Pangaea actually does have a whole lot of overlap, largely because it is still debated on whether or not Gondwana is its own supercontinent. But over the course of the timeline, parts of landmass did gradually drift into Gondwana and kind of just sticking there until we collected enough things for Pangaea to form. So the timeline of when Gondwana officially became Pangaea is a little bit loosey-goosey. Pangaea is kind of made up of two main land masses, Laurasia and Gondwana. While Gondwana was the much bigger one and is the one that is mostly considered to be a supercontinent, Laurasia was the other large landmass that joined with Gondwana to make Pangaea. Pangaea lasted approximately from around 350 million years ago to around 175 million years ago. Now, again, all of these dates are very loosey-goosey with quite a large margin of error because we don't know exactly when Gondwana in Laurasia turned into Pangaea, or split apart or anything. The dates are subject to change as more evidence comes up and as we learn more, but for now, just take all of this with a helping of salt because we don't know the exact 100% timeline for this. Different sources give slightly different dates, so again, grain of salt. Around about 200 to 180 million years ago, again, dates loosey-goosey, Pangaea started to split back up. The land masses of Laurasia and Gondwana started to separate again, and eventually that would form into what we now see as our modern continents. Gondwana and Laurasia split, and then those continents still continued to split until we have all of the modern ones that are around today. Now, these are the most widely accepted ones, again with Gondwana being a little bit controversial, but there are 3 other proposed supercontinents that came before Nuna, so some earlier ones. Those being Valbara, and Kenorland. However, those we have not a whole lot of evidence for, and at least as of now, they are still hypothetical supercontinents, so they did not make the cut for this video, but they do possibly exist and are worth bringing up. So how do we know all of this? Obviously, we weren't there to witness this ourselves, so how do we know that this is true? Well, there's a couple different ways. There's some incredibly complicated geological just procedures that we're not going to go into detail about, but a lot of it is just geology. The same type of rocks were found in multiple locations now that should have only been there if these areas were connected at some point. Same thing with fossils. If there is an identical fossil found here and here, but those are really far away right now, the logical conclusion would be that they used to be close together. That combined with the definitive evidence that plate tectonics are a thing, and anyone who tries to argue that is wrong. We know that plate tectonics are a thing. We know continental drift is a thing. We know that continents move. So with the process that is confirmed of plate tectonics, we know that things move. So logically, if there was a fossil found here and here, they used to be closer together. Same thing, if there's identical chemically and formationally and everything identical rock here and here, they probably were formed at the same spot and just drifted apart. There's also different dating methods that can be used to determine exactly when and how something was formed, how long ago it was formed, and the likely geological and environmental conditions that were happening around the time that it was formed. While more modern and recent supercontinents like Pangaea have a little bit more evidence backing them up, because they are more recent so we have more data available, we can still use these same methods to find out things like Rodinia or Nuna or even the other 3 hypothetical ones that I mentioned. All this to say, Pangaea is not the first nor only supercontinent to have ever existed, and we may be heading towards another one in the future, the far, far future, but in the future nonetheless.